Hi, this is an introductory video that's going to show you some of the different types of formula that we use to represent different organic molecules. So to start with some that you've probably already seen, displayed formula and molecular formula. Displayed formula is very simple. We have the atom represented by a letter. Here we have carbon and hydrogen. And we have the bonds represented by lines between the different atoms. Okay? We have molecular formula on the right, where we have the atom represented by letters again, and we have the little numbers that represent the number of each atom that's in the molecule. So with molecular formula, we don't get told much about the structure of the molecule we're looking at. So one formula you'll have to learn, if you haven't encountered it already, is structural formula. Okay? It's a written formula, as you can see here on the right, and what it does is it shows the different groups of atoms as they appear in the structure of the molecule. Okay? This is best explained through an example. So we have CH3 at the start of the structural formula, which represents in the structure of the molecule, which is drawn out here and displayed, a CH3 at the start. Okay? CH2 in the middle, again we have a carbon and two hydrogens in the middle, and then CH3 at the end. So basically structural formula gives you the tools that you need to go and draw that molecule yourself. Okay? In the second example, CH3 at the start, CH, as shown in the structure, CH, CH3. Okay? So from being given the structural formula, you should be able to go and draw a molecule by knowing its structure, and similarly the other way around, given a displayed formula, you should be able to spell out the structure in structural formula. Okay? So now we've got one for you to have a go at. If you just get a notepad out and try and write down the structural formula for this organic molecule here. Okay? If you could pause the video now and have a go at that, and then unpause when you're ready. Now revealing the structural formula. Okay, it's CH3, CH2, CH2, CH, CH, CH3. So well done if you got that right. If not, I'll just go through it and explain. Okay, again starting at the beginning of the molecule, CH3, and we see a carbon with 3 hydrogens, CH2, CH2 in structural, again going down the molecule, CH2, CH, CH, CH3. Okay, so we can see here the CH, CH next to each other. That really does imply that there's a double bond there. If you're seeing the structural formula first, that's what alarm bells that should be ringing. Okay, the next formula we're going to move on to is the skeletal formula, okay, which probably looks the most scary, but is in fact the simplest formula once you get your head around it. Okay? So skeletal formula, I appreciate this very much looks like lines and zigzags right now, but it really is simple, so we'll go through it now. Okay? In comparison to displayed formula, each edge or corner represents a carbon atom. Okay? So this is the first carbon atom, the corner here is the second, and the last bit is the third. Okay, so these are the carbon atoms here. The bonds, again, quite simple here. They're explained by the lines, similar to the lines here. Okay, going on the second molecule now, exactly the same. The carbon is the edge, then you have the first corner, which is the second carbon, and so on with the final corner and the final edge. Okay? It's just different in this molecule, where we have a double bond shown because there's a double bond. Okay? So that should be simple enough, but the only thing is, what about the hydrogens? Why there are no hydrogens represented, okay? So in skeletal formula, it's assumed that each of the carbon atom, if they're not bonded as shown in the skeletal formula by a line for a bond, then it is assumed that they are bonded to a hydrogen, like so. So while this is not shown with the hydrogens, this is what's assumed, okay? So we get this from skeletal formula, but we assume that this carbon does have 3 hydrogens on. Yes, this carbon does have 2 hydrogens on, and this one also has 3. And similar for this molecule, we can see the carbon atom here has 1, 2, 3 bonds attached that are shown. Therefore, the last one is going to be a hydrogen, which is implied. Now, understanding this factor of skeletal formula can be made easier by the fact that carbon as an atom makes 4 bonds with surrounding atoms, so carbon has 4 bonds. Now what you can do is count the number of bonds that you see. For example, here we have 1, 2. Then you know that the other 2 are hydrogen. 4 minus 2 is 2, etc. And again here, this carbon has 1, 2, 3 bonds that are shown in the skeletal formula. Therefore the last one to make 4 will be a hydrogen. So that's a factor worth bearing in mind. Now I appreciate this might be a bit harder, but here's one for you to have a go at from displayed formula. Can you draw it out in skeletal formula? Okay, so just using the same steps where each edge and corner represent a carbon atom. We have a double bond in there as well, and it should be pretty simple. So pause the video now and give it a go. Okay, now revealing this example, this skeletal formula. Here it is, and congratulations if you got it right, because I appreciate if this is a new concept, this is going to be quite tricky. But for those of you who didn't, I'll just go through and explain it now. We have carbon 1 on the end here, which is the same as this carbon here. Okay, the second carbon is represented by this corner here. And then again, here's the third carbon, the fourth carbon, and the fourth carbon we see is in a double bond with the fifth carbon. And that's shown with this double bond here between the fourth and fifth carbon. And then one more on the end there. Okay? So that's it for this video. And we'll see you again in the next video.